Hey everyone, glad to be here with you, and thanks Daniel for doing that. Even though you're feeling sick, I hope you do get better. Yeah. So today I'm going to share with you all about composables and how we can write better composables. So first of all, I want to give a quick overview of who I am. If you're not familiar with me, which is probably most of you, I do this whole Vue education thing full time. I'm self-employed. I create courses and things like that. Um, I have a podcast called Deja Vue with Alex Lichter. You'll see him tomorrow give a talk, and we've got a bunch of awesome episodes on there. I think we're approaching 50 episodes now. We've got different guests on there and deep dives into technical topics in the Vue and Nux ecosystem, and it's pretty awesome if you ask me. But of course, I'm a little bit biased. I also have a newsletter that I send out every week on Wednesdays, specifically with Vue and Nux tips and articles and events and all sorts of stuff in there. So if you enjoy that kind of a thing, uh, that's there for you. I'll share all these links at the end of my talk. And as Jen mentioned, I also am the instructor for Mastering Nuxt, which is the official course on Nuxt. And we finished recording that one about 2 years ago now. And so we do have some news on that, which I'll share at the end as well. And of course, I've got all sorts of different kinds of content. I did say that this was my job. So I'm, every day learning about Vue, learning about Nuxt, figuring out the latest features, figuring out how to use them better, and creating courses and books and talks like this, videos, all that sort of stuff, so that I can learn some things and then teach it to all of you and hopefully help you out, make your development lives a little bit easier. So with that said, the first pattern that we're going to cover today is the flexible arguments pattern. So in this example here on the left, we've got, your standard composable example, a counter. We define the count as a ref at the top, and then we've got some methods to increment and decrement it. And on the right-hand side, we can use that composable in a component. So pretty straightforward, nothing too interesting going on here yet. But if we want to, let's say, change the default value or the starting value that we're going to start our count with, to do that, we need to add in this argument, and we can set the argument to have a default of 0. And then on the right-hand side where we have our component, we can pass in 38 and or any other number that we want, and we can, get it to start on any number. So, okay, that's pretty straightforward, not too interesting yet there. But what if we want to use a ref? Very often we end up with refs from other places. For example, if we have a data store or a Pina store somewhere, we might get that count ref from that store. Or if we're using Vue use and we're connecting it up to local storage or session storage, we might get our ref from that composable. So what if we want to pass that ref in and then use that as our count? Well, we actually don't need to change anything at all, because the way that ref works is if we pass in a ref, it will just return that ref back. But if we pass in a value, like a JavaScript value, like a number or a string or any of these, it will wrap it. So it has these sort of two modes of working, where in one case, it will give you the ref back, or it will wrap and create the ref. So no matter what we pass in to this composable, we actually get that ref back. And if we look at the TypeScript for this, we can see that Vue provides us with this maybe ref or getter. And that's exactly what this value is. It's a number, and it might be a ref and it might be a getter, but the very least we know that it is a number. So it could be one of these 3 different values. And if you're not familiar with what a getter is. It's basically just a function that returns a value. So if you pass that in to the ref, it'll use that to set up the value, and we go from there. So no matter what we pass in, whether it's a number or a ref that has a number, we can use that reactively within our composable. We can also do sort of the inverse or opposite, depending on how you think about it. So let's look at this composable here. We have use logger, and we're going to take in a ref. And every time that that ref changes, we will log it out. So when we use it in our component, we define this ref with hello world. We pass it into the logger. It'll log it out immediately because we're using watch effect. And then if we change that value to hello Vue Nation, then it'll log that new value out because it's reactive. But what if we don't have a ref and all we have is just a string? Now, in this case, this line here no longer works because a string does not have a dot value property. So what can we do? Well, we have this method in Vue called toValue, and we can use that, and it does effectively the opposite of what ref does. And no matter what we pass into toValue, it will take that and return the raw underlying value back to us. So if we pass in a ref, it will unwrap that, give us the value. If we pass in just a plain string like we have here, it will just give us back that plain string. And we can look at the types again, and here we get the exact same type. We either get this plain value, a ref, or a getter, and no matter which one of these we pass into toValue, it will return back that underlying value. And so again, in this way, if we need to use this raw value in our composable, we can set it up in this way using toValue, and it doesn't matter how we, like what values we pass in, it'll always work. And so that is the flexible arguments pattern, that when we need a value to be reactive within our composable, we will use ref. And if we need it to be a primitive, non-reactive value, then we can use toValue to extract that out. And we'll see how to use this more in the third pattern that I'll share with you today. And again, just to summarize, the benefit of this pattern is that no matter how we use the composable, we can make it work. So many times I've written composables where it expects a ref, but I don't have a ref, or it expects a string, but I actually have a ref of that string. And rewriting your composables to use this pattern allows you to work them in any scenario. The second pattern is the data store pattern, and this is maybe one of the more controversial ones, I'll say, but also one of the ones that I think is the most valuable. And I actually had someone who took one of my workshops in which I shared this pattern, and he came up to me about a year later and said, at first I thought this pattern was kind of useless, but eventually we actually started to use this everywhere in our code base. So maybe you'll be one of those people who says, why would you use this? But eventually you'll come around to it. And here we're going to solve some problems with state management. So we have a bunch of different problems. We have prop drilling, we have event frothing, and we have cousin components. So you've probably heard of prop drilling before. It's where we pass props down layer after layer after layer after layer, and these props are not even used in these intermediate layers. They're just components that are taking in a prop and passing it down to the next component. And this has all sorts of problems. It makes your code really tedious and brittle. If you make changes, it's easy to break things because you don't realize that these props are getting passed around, and it just creates a big mess. Event frothing is the same idea, but for events. And so props are passed down through the component tree and events are bubbled up. So event frothing is when we bubble these events up and up and up and up through layer after layer of components. And the same as with prop drilling, we have a whole bunch of issues with that. Now, lastly, we have this idea of cousin components. So we've got parent and child components, we've got sibling components, but we also have cousin components. And these are basically just components that live far apart in the component tree. And if we want to have some piece of state that is shared between them, it can be really difficult, especially if we want to avoid prop drilling and event frothing. But the way that we can solve this is through the data store pattern, where we essentially take the state out of the component tree entirely into this separate piece that allows us to inject our state into each component exactly where it's needed. And we will use a composable to do this. And this composable has a few different parts to it. The first part is that we need a global state singleton so that any component can access it. The second piece is that we need to export some of that state so that we can actually share it and use it. And lastly, we're going to add on some methods that work on that state because we like to have methods and functions that work on state right next to the state that they work on so that everything's co-located nicely and we can easily scan our code base and understand what's going on. So first, we're going to set up this global state singleton. So we have this composable use user settings, and we're going to have it basically keep track of different settings that someone might have in a UI. So we've got dark mode, is the sidebar collapsed or not, and the code editor theme here. Now I've set this up to use reactive because it's in some ways a bit nicer than having ref because we can add in this object. I would allow, I think reactive or ref is perfectly fine. I don't have like a strong bias towards one or the other in this particular instance, but I've done reactive here just because it's a little simpler in terms of syntax. But if you have, worked ahead, you might have noticed that there's a problem with this in that every single time we use this composable, it will actually recreate this state. And this state variable will get overwritten, or not overwritten, but it will be a new one created for every single time that we use this, which is not what we want. We want to share this globally. So to do that, we need to move that state value out into the module scope. So now it will only be created once when this module is loaded up. And then every single time we use this composable in all sorts of different components across our application, it will still reference the same state variable here. The second part of this is to actually extract some of that state. So for now, we're going to leave the theme aside. We're going to say that we're going to keep that private in a way. And so what we're going to do here is look at dark mode and sidebar collapsed. And you'll notice here that at this first line that I've highlighted, we use two refs on our state. And what this does is it wraps every single value in our reactive object with a ref. And this is important because it allows us to pass around each of these variables individually. And so we can give a component just the dark mode value or just the sidebar collapsed value. We don't have to give it the entire state object all at once. But also, when we do this, it will still maintain that reactivity back to this original state object here in our user settings data store. If we want to use this in a component, we would import it. Then we can destructure this dark mode value off of it. Because we've already done the 2refs, we don't need to do it again here. And then we can use it just like we would any other value. We can toggle it, we can use it in our template, and so on. The third and final piece of this pattern is to take this and actually add in some business logic. So now we'll address this theme setting that we've got. So we're pulling it out of our state here using 2refs, and at the end we're returning it, but we've wrapped it in a read only because we don't want anyone to just be able to modify it however they want. Instead, we're going to add in our own change theme method. And this method basically just checks against a predefined list of themes so that we can guarantee that the theme that they're trying to set it to actually exists. And if so, we can actually reference state.theme directly, and we can update our theme. And that's all that we need to do. And we've got a nice business logic method in here to modify our state. So those are the three pieces of the data store pattern: the global state singleton, exposing some of that state using the 2refs, and then adding in business logic to work on that state. At this point, this is where we get to the controversial point, and you may be wondering, okay, well, okay, I missed some slides here. I got ahead of myself. Of course, you have to export the function, and there we go, some highlighting on it. You might be wondering at this point, oh, well, why not just use Pina? Like, isn't that what we have Pina for? And that's a very good question, which is why I have this slide. And this is something I've actually talked to Eduardo about a couple of times. Eduardo, who is the creator of Pina, and we actually had one of these conversations on the Deja Vu podcast. So I highly recommend you go check that out. We talk about when to use Pina and when not to use Pina, and also how to use Pina and a bunch of other things. And there's a few things I'd like to mention here, and that is, first of all, this pattern is nice because we can understand what Pina is actually doing a little bit better. So even if you never use this on its own and you only ever use Pina, now you have at least a bit of a better understanding of what Pina is doing. Number two is that this is a simpler method. You can simplify it and have it be just what you need it to be. And because it's your own code, you can have it do whatever you want. You can have it return just a plain object. You can have it return a single value or literally anything because, it's your own code. You can do whatever you want with it. However, there is the downside in that it is not a battle-tested piece of code. It doesn't support SSR. It doesn't hook into dev tools. But there are these other things to consider. And just to be clear, I would like to state that I'm not saying you shouldn't use Pina. I'm just trying to explain that if you want, there is this alternative. Like the person who took my workshop, you might end up using it and might find value in this. So I have one last pattern before my time is up here. And this is a bit of a shorter one. And the idea with this pattern is that we want our composables to be a thin reactive layer around some plain old JavaScript or TypeScript code. And this is beneficial for a couple of reasons. It makes it easier to test, makes it more modular. It's not tied to Vue or any specific library or framework. And generally more modular, less coupled code is better for a bunch of different reasons. So we've got this composable here called use greeting. And we take in a user from our data store, and we have a computed value here that computes a greeting for that user. And that's all that this one does. And if we have a user, we return one thing. If not, we return a different thing. So the first thing that we're going to do is create a new file called user logic, and we'll just add this greeting method in there as a plain old JavaScript file. And we're going to make this a pure function. And a pure function is one where all we're doing is taking in an input and then returning a value. It doesn't do anything else. And this type of function is super, super simple to understand, but also really easy to test because there's nothing fancy going on. There's no reactivity. There's no other funny business happening. It's very, very, very straightforward. So we add this method in, and then we can come back to our composable and we can refactor it to use this method instead. And the key piece here is this user.value where we're unwrapping that reactivity in order to access that name, that we can pass that just plain old JavaScript value into this function. And so you maybe remember from the first pattern that we looked at, we can use toValue instead, and it will always unwrap that ref or whatever value we pass it to give us the underlying value. And if you, so that's the end of my talk. Those are the three patterns I wanted to share with you today. If you want to know more about composable design patterns like this, I, a few weeks ago, released an entire course on this, and it has 16 of these patterns. We go really in depth and discuss the trade-offs and the pros and cons of the different things. And we have step-by-step examples of how to refactor using these. And you can find that at my website /composable design patterns. I think if you Google that, you'll also find it. I also said at the beginning that we had some things to share about mastering Nuxt. Well, it's been about 2 years since the last one was recorded, and 2 years, some things have gotten out of date, which is why we are recording the entire thing again. Where I'm actively working on it. Actually, I was just before this talk working on the code base, and we will be completely re-recording the course. Existing customers will get it, which is good news because it's 30% off right now, which means you could buy it right now and learn a whole bunch of things, most of which has actually not changed a whole lot because the fundamentals of using Nuxt are still the same. And then when the new one is released at some point in the near-ish future, then you can, get that one and go through that all at the same time. And you can find that at masteringnuxt.com. And that is it for me. Thank you for watching and paying attention. And I hope you learned something valuable from this talk. Here are a bunch of my links. You can find me in basically anywhere.
Thank you, Michael. We do have quite a few questions for you.
All right.
Up first, if there were only one pattern to teach someone how to write better composables, what would it be?
Oh, wow. That's a hard question. I think the flexible arguments one applies to most composables. And I think most composables would benefit from that.
All right.
Yeah.
What's an advantage of writing a composable for the purpose on your own instead of simply using Pina?
Yeah. So it's yeah, basically like what I was saying, if you want something um that's just going to be like you want to return a specific type of value, you want to return an array or just like a single value instead of using the reactive object that PNU returns, then you can use that as well.
All right. And should someone use a Pina store inside the composable instead of moving the state outside of the function?
Yeah, so I think if I understand the question correctly, then yes, you could. Yeah, you can just use a Pina store in your composable, and Pina manages all of the making sure things are global and all that.
Thank you. Data store is an interesting pattern. Do you know if it's lighter than Pina in terms of, for example, component mounting time?
I haven't tested this, but I would imagine that Pina has. I think Pina is quite lightweight already on its own, but I would imagine that because you're just writing the code that, like, literally just the code that you saw on the slides here, it's going to be a lot less, and um, whether that actually translates into measurable terms of measurable difference, I don't know. But it wouldn't be slower. I'll tell you that much.
All right, last question. How to manage types when using read only with a or data store pattern? Do they need to type all consuming functions components with read only as well?
I actually don't know about this one. Um, I don't know, but that's a very good question.
All right.
I'll have to look into that one.
We got a awesome. Well, that's it for us. Thank you, Michael, for joining us today. We greatly appreciate